So as I said, we're gonna just skip a little bit from this lesson. It's just exploring. I'm gonna go into explaining the formula. We're gonna use the formula. So here's something that I want you to do on the calculator. Okay? If you have 16 to the power of 1 over 2. So on the calculator, you're gonna do 16 power of bracket 1 over 2. So make sure that when you're putting your power button, then you're going to put bracket 1 divided by 2. What do you guys get? 4. Okay, so make sure that you enter it and make sure you get that, please. Okay, now what if you do this? What if you do square root of 16? What do you get? 4. Okay, let's try something different here. Let's do
sorry, can I ask you a quick question?
Yeah.
Please?
Go ahead.
I did 16 raised to the power of 1 divided by 2. I just got 8.
Did you put,
I now put it in bracket, I got 4. What's the difference?
because you have to put the bracket,
I have to put
okay? Because otherwise what it's doing 16, right, to the power of 1, and then you're dividing by 2, right? If you don't put the bracket, that's what the calculator is doing, okay? So it's just raising 16 to the power of 1, which is 16, and then dividing 16 by 2, right, which is 8. But that's why you need to put power, and then you need to put your exponent itself in bracket.
Because the exponent is half.
Yes.
Okay.
Okay? Now try this. What's 125 to the power of 1 over 3? Well, yeah. So if you're going to enter this in the calculator, you're going to enter it as 125 power of 1 divided by 3. What do you get for that?
5.
5. Now, let's look at this. In the cube root of 125, what does that give you?
5.
5. Okay, I want you to keep track of what's happening here, okay? Now, let's try this. (32) to the power of 1 over 5. What do you get?
2.
So what are you getting if you do 32 to the power of 1 over 5? 2. What if I do the 5th root of 32? What do you get?
2.
Do you see any connection here? So you see that I'm getting the same answer if I raise 32 to the power of 1 over 5? What if I do the 5th root?
How do I do the next?
Should be able to do 5 and then be 10 or so you should be able to see that up right here. 5 shift this button. Shift 5. 5 first. 5. Shift this. Good. No. 5. Shift. 32. So you should be able to see on your calculator. You should be able to see on your calculator something that looks like this, and that would be your nth root. So you should be able to see something that looks like this. Okay? Now you can enter whatever number first. So you can do 5, you press the shift button and then this symbol, right? And that would give you the 5th root. Make sure you find it. If you can't find it, call me. Okay? So, do you see any connection? So if I do 125 to the power of 1 over 3, I'm getting 5. If I do the 3rd root of 125, I'm getting 5. Do you see any do you see anything happening between the two different forms?
The denominator
The denominator of your exponent
gives you the same answer.
gives you the same what? In where?
In the root.
In the root.
Yeah, in the root.
So you see that if you look here, that denominator is your root. That denominator is your root. And you're ending up with the same answer. So if I raise it to the power of 1 over 3, or if I do the cube root, it's the same thing. Try another one. Give me, let's see.
64.
64. What's 64? 2 to the power of 6. Okay, so let's try this. 64 to the power of 1 over 6. What do you get? What's 64 to the power of 1 over 6?
2.
2. How about the 6th root of 64? 2, right?
Wow, this is magic.
So this is two different formats. Okay? It's exactly the same thing. I'm doing exactly the same operation, but differently. Okay? Written differently. So this format, we call this format the rational form. Okay? I can write this, which is a to the power of 1 over n, as the nth root. Whatever this here is going to go in the root of a. Okay? This format is called the radical format. So that's the root format. It's called radical. So rational is when you have a fraction of an exponent. Radical is when you have a root. Okay? Two different names. They're exactly the same thing. Okay? So, if I give you this, and I tell you to put it in, write it in radical format for me, what would it be? 7th root of a. Okay? If I give you this, and I ask you to write it in rational format, what would you write? X to the power of 1 over 10. So you see that? You see that? Whatever is in the radical is going to be in the denominator of your exponent. Why is my numerator 1? Why is my numerator 1? What's the exponent on the a right here? Inside. That's one. Right? What's the exponent on this x? 1. So it becomes 1 over 10. We're going to see that in the next part. Okay? What if I don't have 1 as my exponent? So, here's what I want you to do right now on the calculator. So, do we understand this formula? So, the rational and the radical right? Whatever is in the denominator is going to go in the root. Now, let's look at these examples. Find the answer for me. So 64 power bracket 2 divided by 3. So this is what you're entering in the calculator. 64 bracket, exponent, bracket 2 divided by 3. That's what you're entering in the calculator.
16.
So she collected them all herself. She's not supposed to have it. She's not supposed to have it. She did. It's just they all she just wants them all traded in.
Okay, so what are you getting for this? 16. Okay, now let's look at this. I want you to enter this in the calculator.
16 too.
You tried it?
Yeah. Magic. Yeah, nothing else.
It's 16, huh?
Yeah.
Yeah?
Why is it happening?
Why?
Yeah.
Why is this happening? What do we know about the cube root? What is it? If I want to write it as a rational format, what is it? 1 over 3, right? So if I look here, right, that's the same thing as 64 to the power of 2, and then raised to the power of 1 over 3, right? Yeah? Because I know that the radical is 1 over 3. Okay? Now, if I have exponent to the exponent, what does that mean? What do I do?
Multiply.
Multiply. What's 2 times 1/3?
2 over 3.
That's 2 over 3, right? Right? So whatever is, look what's happening. Whatever is in the denominator of the exponent, we know that it's going to go in the root, right? And whatever is in the numerator is going to go as your exponent. Okay? So whenever you have the rational format, your exponent is your exponent for the base, and then the denominator is the root. Okay? So I can write this, if I'm looking at it as a general form, that's the what root? What do I put in the root?
And
N of A
to the power.
to the power of n. There's two ways that you can write this. You can write it like this, or you can write it like this, and it's exactly the same thing. I usually write it like this. Okay, the first one. But they're exactly the same. Okay? So, remember, we call this rational. We call this radical. And if you enter them both in the calculator, this should give you the same answer. Okay? Now it's up to you which way you want to type them in the calculator. All right. So we're going to take this formula, and then we're going to see what we can do with it. So we said that a to the power of m over n is the nth root of a to the power of n. And we said that I can also write it like this. Okay? So the conditions that I have to meet is m has to be an integer, so m has to be a whole number. N cannot equal to 0 because I cannot divide by 0. Okay? We call that as a natural number where n is greater than 0. And most importantly, a cannot be negative if n is even. So a has to be greater than or equal to 0 if n is even. Okay? So let's see why is that. Can you take the square root of a negative 16? Do that on your calculator. Can you do the square root of a negative 16? No, it's going to give you an error. Right? Can you take the fourth root of negative 16? No. Can you take the cube root of negative 16? So if this is a 3, can you do a 3? Can you do a cube root? Yes. Yes, that's going to give you a negative answer. So if your a, which is your base, is negative, your root cannot be even because you can't take the root of a negative number. Okay?
My calculator gave the fourth root of negative 16. I don't know if it's right.
I probably did not put the negative in the bracket.
Oh, please no.
You did not. It shouldn't give you the fourth root of a negative. Is this an imaginary number? It will give you an imaginary number. It will give you an imaginary number. Don't. Yeah. There is imaginary numbers, but we don't learn them here. Okay. So, the question will be asking you to either write it in rational or radical. You have to understand the difference between the two. Radical means root, and rational means exponent with a fraction. Okay? Let's see this. Can you write this as a rational exponent? How would I write that as a rational exponent? What do we call this? Square root. So there is a invisible what here? 2. Okay? So that will be 25 to the power of what? 1 over 2. Okay? Yes, it's not there because that's your base, square root. It's called a square root. Okay? So there's an invisible 2 there.
Maya, sorry, quickly for dragging.
Yep. What is it?
When you use the cube root of negative 16,
Yeah.
I got an answer.
Yes.
But if the number is even,
If your exponent is
if you're
even,
you're not getting anything.
yeah, you're going to get an answer here, right?
Yeah.
But if you do the square root or the fourth root of negative 16, you're gonna get an error,
Error. Okay.
okay? Because you can't take the root of a negative number. Why is that? What's the, okay, now this is a, okay, here's the thing. If you have negative 4 squared, what are you gonna get? What's negative 4 squared? 16. It's going to become positive. It's going to force it to become positive, right?
Yeah.
It's going to force it to become positive. So anytime you square something or you do something to the power of 4, to the power of 6, or to the power of 8, your answer is going to become positive. So there is no square or fourth answer or to the power of 6 answer that's going to be negative. That's why we can't do the opposite operation, right? Because this is never going to be a negative. Right? So I can't do this because it's, well, if I square it, it's going to make it positive. Right? So that's a totally like different lesson right here. Why is that? Okay? But you should understand that you can't take an even root of a negative number. Okay. How can you write this as a rational exponent? So bracket, negative 125, close bracket, to the power of 1 over 3. Good. How would I write my next one as a rational?
1.53.
0, 5 to the power of 3 over 4. You see that whatever is under the radical, under the root, I'm putting it in bracket. Okay? So in the case of the negative 125, I put the negative 125 in bracket. Use that. Okay? Always use it as an example. Put it in bracket. Okay? If you have, let's say, a radical of 7x, let's say, okay? Put that 7x in bracket to the power of 1 over 2. So whatever is under the bracket, under the radical, is going to go in bracket. Okay? Make it as a rule. Whatever is under the radical is going to go in bracket. Okay. We're going to do this question and we're going to stop. I'll teach the rest tomorrow because otherwise you are going to probably kill me. All right. Okay. 81 to the power of a half. How would I write that in radical form? Excellent. Do I need to put a 2 here?
No.
No, it could be invisible. Okay? Because the square root is the base. And have you ever written 2 for the square root?
Maya will need to explain everything to you.
No.
You don't want to lose
I already
any,
explained it to
you
you.
don't want to lose any 0.5 marks. That's all.
I've already explained it to you. Okay, how would you write this as a radical?
Square root negative 60.
Square root?
No, cube root of negative.
Cube root of negative 64.
And then
Show your work.
That's showing your work. It's right there.
5 root
The fifth root,
Cube
yeah.
Of 32 raised to the power 4.
to the power of 4.
Good. Okay, now if you look at this question saying rewrite each expression in radical form, which we already did, then evaluate. So you guys can do that. You can evaluate and give me the answer, right?
Yes.
What is that, negative 4?
Negative
16. Okay, I'm gonna stop right here.